Right, application services. These are basically runtimes and frameworks, and they allow development and hosting of apps in the cloud. Uh, Typical examples. We go through a few examples that we already find online, especially hosted already. For example, but okay, before I proceed to look at typical examples of application services, let's look at the diagram on the right. Here, notice that we have normally cloud applications that have got users. There are various types of users, of course. We will call some the general user, and then developers. These normally have a way to access these applications. The first example is where a user will access the application via a web browser or a dedicated client which accesses the application which is on the server. A typical example, of course, is the email service, which allow you to send and receive emails and do all sorts of things, operations that you can perform on an email server, cloud applications. A typical example is Gmail, of course, and Outlook. There are a lot of others that are also available. Right. Then it's all perfectly possible. The second type is where you have a user who is running an app, and this app could be running on a mobile device or something like that, and then some of the functions are in the cloud, so you have sort of some extra functions that extend the functionality of the local application that you are using. Then finally we have application developers. They use an application which might actually execute code on the cloud, and then have the application running on the cloud, and it interacts with the cloud. In other words, you develop, write your code, deploy it on the cloud platform, and it runs as an application on the web. So those are the typical scenarios that you might come. Right, queuing services are an example of an application that is very useful and popular. Especially, it's actually used in the architecture of applications, and it allows decoupling of services, especially if they are doing message passing. It avoids a scenario where you have a single point of failure. Applications can continue running, putting their input into a queue, and another component could be taking that information in the queue as input, but it doesn't depend on when the other application is running or not. All components can run independent of each other, independent of whether the other one is up and running or not. And so we use it to avoid single point of failure and to reduce bottlenecks and so on. So they allow decoupling of app components by allowing asynchronous inter-component communication via message queues. So it's basically a framework for message passing. Then queues also serve as overflow buffers, where there is a mismatch between message generation and consumption. Right. This is a scenario where you have a producer and a consumer. If a producer produces more than what a consumer can consume, you need somewhere to store it, isn't it? So that the consumer can operate at their own rate, while the producer constantly keep on producing. So it doesn't allow the producer to just wait to allow the consumer to consume the message. Right, of course, email messages I've referred to this many times. There are also what are called notification services, which are very useful. They push message services. They allow apps to push messages to connected smart devices based on publish and subscribe model, usually. In other words, those that are interested in specific messages on a particular subject can subscribe to topics, like what we learned in this course in the Cloud Internet of Things protocol, called MQTT, message telemetry transport queuing system. So it can be used for Internet of Things. These notification services, they are actually ideal for that scenario. Okay, we can also have media services as an example. These provide various types of media services that can be used by cloud apps to manage media such as images, videos, and sound. You already know that there is things like Spotify, which are sound-based. Videos like YouTube, they are also cloud-based. Images, things like Pinterest, and any other imaging photo service would be useful. Right, on the right you see a diagram that sort of summarizes the cloud computing reference architecture, where you have the cloud consumer and the services that a consumer can, the various services that a consumer can get. You get a summary of the types of applications and the types of consumers. Of course, you have it covers the three classes of services, like infrastructure as a service, platform as a service, and also software as a service. So that diagram clearly summarizes the various applications that you can find in the cloud. Right, content delivery networks are yet another important service that probably most of all of us are using regularly, if not every day. Of course, content delivery networks are abbreviated CDNs, and of course typical examples YouTube, but there are a lot of other ones that you may be familiar with. So these are basically, the CDN is basically a distributed system of servers located across multiple geolocations to serve content to end users with high availability and performance. Right, it is useful for serving static content and streaming media, and use caching near where the data is required, and of course reduce bandwidth and improve response time. It's optimized for things like videos. Notice that audio and video are recorded, and after that they become fairly static. They are not always edited, so it's suitable for content delivery networks. Right, analytics is a very important service that you will find in the cloud. Amazon has got a number of services that relate to data analytics. The same with Google, and so on and so on. So these services allow analyzing massive data sets stored in the cloud. In other words, big data. And that's why also they are important for cloud, for Internet of Things, because things generate a lot of data, and so you need analytics to perform these. Of course, this is where you may use MapReduce, which we discussed in our last topic. And apps that use them can perform data-intensive tasks that involve data mining, log file analysis, machine learning, and web indexing. Right, that's the end of section 3. Next we cover section 4, which is also the last section